Good morning, everybody. We're going to talk about double angle and half angle formulas today. You can find these on the bottom of the front page of your note sheet. Okay, so double angle formulas, those were the easiest ones to work with. The first one, sine of 2 theta, ends up being 2 times the sine of theta cosine theta. The cosine of 2 theta is cosine squared theta minus sine squared theta. There's actually a couple different formulas you can use for cosine 2 theta. Here's another one. Cosine 2 theta is 1 minus 2 sine squared theta. Cosine 2 theta is also 2 cosine squared theta minus 1. So it depends on which one is the most convenient for you to use. Okay. So here we go. We've got a problem to work with here. We've got the sine of theta is 3/5. And so that tells me, this part of the problem right here tells me that the opposite is 3 and the hypotenuse is 5. And this part right here tells me it's in the second quadrant because it's between pi over 2 and pi. So the opposite would be 3. Hypotenuse is 5. Now I can use the Pythagorean theorem to find this side. It's going to be 4, but remember, since it's in the second quadrant, it's really -4, so there's my theta right there. That's the triangle we're going to use. So the sine of 2 theta, if I use my formula, is going to be 2 sine theta cosine theta. So this is going to be 2 times the sine of theta is going to be 3/5. And the cosine of theta is -4/5. Adjacent over hypotenuse. So if I multiply all these together, I get 2 times 3 times -4 is -24. And 5 times 5 is 25. So sine of 2 theta is going to be -24/25. Now the cosine of 2 theta, that's going to be cosine squared theta minus sine squared theta. So the cosine is going to be -4/5, and we're going to square that. And then the sine is going to be 3/5, and we're going to square that. So this ends up being 16/25 minus 9/25, which is just 7/25. So these are pretty easy formulas to use. All right, now we're going to establish this identity. So this is the double angle formula for tangent, and we're going to prove that. So that means we can't use the theorem to prove it. We've got to find another way to do that. So here's what we can do. We've got this tangent to theta. We're going to change this to be the tangent of theta plus theta, because theta plus theta is 2 theta. Now, we're going to use our sum and difference formulas for this. So this formula is the tangent. Okay, so here's I've got alpha and beta here, and they're the same thing. They're both theta. So this is going to be tangent of theta plus tangent of theta all over 1 minus tangent theta times tangent theta. And all of a sudden, this is a super easy problem because tangent plus tangent is just 2 tangent. And tangent times tangent is tangent squared, so this is 1 minus tangent squared. So we've proved the double angle formula for tangent. Okay, now we have power reducing formulas. You can find power reducing formulas on the top of the back page of your note sheet. Okay, so they're exactly that. It takes sine squared, and I can reduce that and get rid of the power here, so I can change it to 1 minus cosine 2 theta over 2. The cosine squared is 1 plus cosine 2 theta over 2. And the tangent squared theta can be reduced to 1 plus cosine 2 theta over 1 minus cosine 2 theta over 1 plus cosine 2 theta. So these let me reduce powers down when I've got something that's kind of by itself and I can't get rid of it any other way. So we're going to use that to look at this. Prove that cosine to the 4th theta is 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. All right. So let's start with this. Cosine to the 4th theta. Well, I could rewrite that as cosine squared theta squared. If I square something that's already squared, that's taking it to the 4th power. All right. Now, what I want to do is I want to use my power reducing formula on the inside of this thing. So cosine squared, remember from our power reducing formula, is 1 plus cosine 2 theta over 2. And then remember I got this squared right here, so I got to leave that right there. Okay. Next. Okay, so then this can be rewritten as 1 plus cosine 2 theta over 2 times 1 plus cosine 2 theta over 2. That's what squared means. And I can actually break this apart and make it 1/2 plus cosine 2 theta over 2 times 1/2 plus cosine 2 theta over 2. Now I want to FOIL this. So first, 1/2 times 1/2, that's 1/4. Outside, 1/2 times cosine 2 theta over 2 is going to be cosine 2 theta over 4. Inside, it's going to be the same thing. Cosine 2 theta over 4. And then last is going to be cosine squared 2 theta over 4. Okay. So I've transformed this into this, and I can actually combine these right here. So this is going to be 1/4 plus 2 cosine 2 theta over 4 plus cosine squared 2 theta over 4. And then, of course, that cancels right there, and I end up with 1/4 plus cosine 2 theta over 2 plus cosine squared 2 theta over 4. Now, I've simplified that quite a bit, but it's still not what I want it to be. Okay? I don't want any powers here. So I have to power reduce this one again, which is going to be, I'm going to have to pay attention to this. Okay, so my formula here, this first part, mostly done. It's this part we got to worry about. So this is, when I use my power reducing formula again, this is going to become 1 plus cosine. Now, it's cosine 2 theta, but it's already 2 theta, so this is going to be cosine 4 theta, okay, over 2, but it's already over 4, so 2 times 4 is going to be 8. And now you might be able to see where this is going to go, because I'm going to break this fraction up. Into 1/8 plus cosine 4 theta over 8. And now I can combine my 1/4 and 1/8, that's 3/8. I can write this as 1/2 cosine 2 theta. And this is 1/8 cosine 4 theta. And that's what we wanted right there. So there was a lot of algebra in there. We had to use our power reducing formulas twice, but we got her done. Okay, projectile motion. So an object is propelled forward at an angle theta to the horizontal with an initial velocity of v feet per second. If air resistance is ignored, the range r of the horizontal distance that the object travels is given by r equals 1/16 v naught squared. Okay, so v naught is in feet per second, times the sine times the cosine. Show that r equals 1/32 v naught squared sine 2 theta. Okay, well, here's the thing. Remember that this part right here, that looks like a double angle. Here's my double angle formula. So sine 2 theta could be written as this. We could take this and change it to 1/32 v naught squared times 2 sine theta cosine theta. Okay? And then if I put the 2 over here on top of this, that's just 2 over 32, which is 1/16 v naught squared sine theta cosine theta. So this and this are exactly the same thing. Or I should say this and this are exactly the same thing. Okay, for which angle theta, find the angle theta for which r is the maximum. So if we want the maximum range, then what is the angle, what angle do we want to fire this thing at? So if you keep in mind, the angle theta is this, okay? So we want this to be a maximum value. We want the sine, because the 1/32, you can't do anything with that. That's just 1/32. This also is a constant. It depends on the velocity, okay? It can't change. This is the only thing that can change, is the angle. So if we want the angle to be maximized, we want this to be the biggest possible number we can, okay? And the biggest that the sine gets is 1, and that's at 90 degrees. And so the only way that I can get 90 here is if I put 45 in for theta. Okay, so 45 would be the maximum. We want this angle to be 45 degrees right here, because then when I double it, I get 90. That gives me 1 right here. Anything less than 45 gives me a fraction that's less than 90 degrees here. Okay, I can't do anything about this part. It's all constant values. This is the only part I can change. I want that to be 45 degrees. That's as big as it gets, and that maximizes my range. Okay, so I've got some half angle formulas here. The sine of alpha over 2 is plus or minus 1 minus the cosine of alpha over 2. The cosine of alpha over 2 equals plus or minus the square root of 1 plus the cosine of alpha over 2. And the tangent of alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Now the plus or minus, we'll talk about that in a little bit. Okay, sometimes you have to adjust the angle to get it to work correctly. So use a half angle formula to find the exact value of cosine of 15 degrees. So my half angle formula is bottom right corner of the front page here. So cosine here is going to be theta over 2. So my theta, this implies that theta is going to be 30. Okay? So my equation then is going to be plus or minus the square root of 1 plus the cosine of 30 over 2. All right, so then that's the square root 1 plus the cosine of 30 is going to be square root of 3 over 2 over 2. Now the question is this thing positive or negative? Okay, 15 degrees is in the first quadrant, okay? And so remember, all students take calculus. It's got to be positive in the first quadrant. So this is going to be positive. I can just leave it positive, and I don't need the plus or minus anymore. There's my exact value. I really can't write that in any other way. I could put it in a decimal, but that would change the value. Okay, what about the sine of negative 15 degrees? Okay, so again, this is going to be plus or minus the square root. I get my formula for half angle for sine. That's going to be 1 minus cosine of negative 30 degrees over 2. Okay, so then let's see, the cosine of negative 30 degrees, that's going to be, hang on here. Cosine looks like this, negative 30 degrees. That's going to be square root of 3 over 2, and it's going to be positive. So this is going to be 1 minus the square root of 3 over 2 all over 2. Now, since this is a sine, okay, the sine in the fourth quadrant, which is where negative 15 degrees is, sine's negative down here. So sine of negative 30 degrees is going to be negative. Sine of negative 15 degrees is going to be negative. So this is going to be a negative angle right here, or a negative answer. And I'm done with that one. I can't really do any more with that. Okay, cosine of alpha is negative 3/5. You're in the second quadrant. Find the exact value of the following 3 items. Okay, so let's draw a picture of this thing. We're going to put the negative up here. Okay? And so it's in the third quadrant. So the triangle looks like this. Here's alpha. And the adjacent's negative 3. Hypotenuse is 5. If I use the Pythagorean theorem, I find this side's 4, but it's negative because it's in the third quadrant. Okay, so now I can use my half angle formula here. So this is going to be equal to plus or minus the square root of 1 minus cosine of alpha over 2. All right, cosine of alpha is going to be negative 3/5, so this is going to be plus or minus the square root of 1 minus negative 3/5 over 2. Okay, and then my negative signs cancel out here. I can think of this as 5/5. So this is going to be plus or minus square root of 8/5 over 2 over 1. We're going to make it 2 over 1. We're going to invert and multiply. So this is 8/5 times 1/2. which is 8/10, which is 4/5. So this is the square root of 4/5, which is 2 over the square root of 5, which is going to be 2 square root of 5 over 5. Okay, now I need to determine, is it positive or is it negative? So, my sign in the third quarter is going to be negative. Let's see. Oh, that's alpha. Okay, so now we got to think about, is this thing positive or negative? So let's think about what this angle is. So on our unit circle here, we are in this quadrant right here. This is angle alpha right here. Okay, and we want to know what's the sine of alpha over 2. So here's my alpha angle. Half of that is going to be up in here. Okay, remember, all students take calculus. All positive, sine is positive. So half of angle 2, or angle alpha, is going to be up here. It's going to be positive. So this is going to be positive 2 square root of 5 over 5. That's the hardest part of this whole thing. All right, so let's kind of get all this out of the way here. Oops, I didn't include that, I guess, so just make that go away. All right, let's look at cosine of alpha over 2. So our formula for that, cosine of alpha over 2 is going to be plus or minus the square root of 1 plus cosine alpha over 2. Okay, so here, this is going to be equal to plus or minus the square root of 1. The cosine is going to be negative 4/5, so 1 plus negative 4/5 over 2. And again, we're going to change this to 5/5, so we can get a common denominator. So this is plus or minus the square root of 1 over 5 over 2 over 1. And we're going to invert and multiply. So that's 1/5 times 1/2, which is the square root of 1/10, which is just 1 over the square root of 10, which we rationalize, and we're going to get square root of 10 over 10. So now the question is it positive or negative? So we go back to that same picture. Okay, here's my angle is all the way around here. Now half of that is going to put me up in here again. Cosine, all students take calculus. Cosine is going to be negative over here, so this is going to be negative. Okay, finally the tangent. So the half angle formula, this is going to be 1 minus cosine theta over sine theta. This is actually the easiest one here. So the cosine, this is going to be 1 minus the cosine is negative 3/5 over the sine, which is negative 4/5. Okay, so these cancel. Again, let's call this 5/5 right here instead of 1. So then I get 8/5 on top, divided by -4/5 on the bottom. So that's 8/5 times -5/4. And then the 5's cancel, the 4's cancel, and I just get -2. -1 times 2 is -2. Okay. So there's some alternative half-angle formulas you can use. I believe these are on your note sheets. And that's it. So your assignment today. Oh, my picture's gone here. And I don't know what happened there. So, anyway, there's your assignments. You're going to do 1 through 19. And I will see you next time.